Hello and welcome back to our YouTube channel Axelbuzz Testing. Learn testing in easy, simple way. Today we are learning database testing. Our today's topic is acid properties in database, and I will be covering basic test scenarios to check acid properties in database. So let's get started. There are certain properties should follow while read and write the database in the database management system. So these are acid properties. A. Atomicity. C. Consistency. I. Isolation. And D. Durability. So we'll see all these properties one by one. If any operation is performed on the data, either it should be performed or executed completely or it should not be executed at all. Operation should not break in between or executed partially. This is what atomicity says. Means what? If let's consider one example. We are transferring one amount from A to B. There are few steps from A side and then few steps at B side. Then what atomicity says operation should perform completely before commit. If system breaks at some point, then everything should roll back and means it suppose A is transferring some amount to B, suppose 3000 rupees A is transferring to B. While doing this at some point the system crashed, then all the operations should roll back and none of the operations should perform and A should not be able to send amount to the B. So this is what atomicity says. See, now we have written some positive scenarios and negative scenarios to test the atomicity. Let's consider one by one. Positive scenarios. Start the transaction, complete the transaction, perform all the steps given like credit, debit, and the money, and check the result. If the result is proper, then you have passed in atomicity. Negative scenarios: start the transaction and don't complete the transaction. Send money from A, but it should not receive by B. Give wrong credential at that point to B. Then what else you can do? While doing the transaction from A, try to fail the transaction and then check the power failure and even internet failure you can check out. In all these points, if all the steps are getting performed properly, then your test cases are passed in atomicity. Next is C for consistency. Consistency means changes should remain always constant. Data should be in consistent state when the transaction starts and when it ends. Let's see the consistency with this example. Suppose A wants to send 1000 rupees to B. A has currently 3000 rupees in his account and B has currently 1000 rupees in his account. So first, whenever arithmetic operation will start, it will check first whether A has enough money to send or not. If A has more than 1000 rupees, then arithmetic operation will perform and 1000 rupees will be deducted. So A will have 3000 minus 1000 will be 2000 in his account and it will be stored in local memory. Then transaction will check whether B has and then it will read B's amount and it will add 1000 rupees to B's amount, means 1000 plus 1000 B will have 2000 rupees in his account. So in this transaction where consistency will follow, before and after transaction, if it is same, the money will remain same, then the consistency is there in this transaction. So if 3000 plus 1000, 4000 total amount was there, after transaction there will be also 4000 amount, total amount. So there will be consistency in this transaction. How to check data consistency? First, we'll see positive scenario. Start a transaction, then complete the transaction. Perform all the steps like credit, debit, and the money, and even money, and check the results. If before the transaction and after the transaction money will remain same, then there will be data consistency. You can check internet failure or power failure in negative scenarios to check the data consistency. Third is I for isolation. A transaction is isolated from another transaction, that is, a transaction is not affected by another transaction. Although multiple transactions execute concurrently, if it must appear as if the transactions are running serially one after another. In simple words, if your system is doing multiple transactions at a time, still it should appear like one transaction at a time. All the transactions should go serially one by one. First result will be stored in memory, then second will start. Suppose A is sending some amount to B, an operation gets started. In middle of that operation, A started sending amount to C. Though it is he is doing concurrent operation, but it should finish first B's transaction, then transaction of C should start. If the system is following like this, then it is isolation. Then the isolation property is getting satisfied. Then how to test the isolation? Positive scenarios will be send the money from A to B and before the transaction ends start sending money to C. Verify the isolation. First it should complete B's transaction, then the result will be stored in the memory, and then based on the result transaction of C should start. Negative scenarios will be start a transaction and before it gets tried to start another transaction, and start a transaction from A and before it reaches to B, start a transaction from B. Means B should send some amount to somebody before A's amount to about to receive. So like this you can check the isolations scenarios. D for durability. In DBMS, the term durability ensures that data after the successful execution of the operation become permanent in the database. Whenever you will retrieve the database, the data should remain constant. For example, if flight booking, the reports that a seat has been successfully been booked, then the seat will remain booked even if the system crashes. Then how you will check the durability? Positive scenario can be start a transaction and complete it, and then check the durability after commit. Negative transaction, just now I have told, like book the seat, try to crash the system or shut down the system or server for shorter or longer time, and then check the durability. You can test with the internet failure, power failure, like this. So these were four checks ideally every transaction should go through. If you like this video, please hit the like button and subscribe to our channel if you haven't subscribed yet. We'll be covering remaining DBMS testing in our upcoming videos. If you want any other topics to be covered, let us know in comment section. Till that time, stay tuned, stay connected. Happy testing. Bye bye.